How are you, my boys? We start today the remaining problems on capacitance and capacitors. Two metallic conducting spheres are connected with a wire and charge Q is given. This charge is distributed between the spheres such that their charges are Q1 and Q2 respectively, and they are at common potential V. The capacitance of the spheres are C1 and C2, radii R1 and R2, and surface charge densities are sigma 1 and sigma 2 respectively. Then we have to find the correct one or ones from the given four options. এখানে আছে দুটো পরিবাহী গোলক, তাদের মধ্যে তার দিয়ে সরু তার দিয়ে জয়েন করে দেওয়া হয়েছে এবং আফটার অল এই রেজাল্টগুলোর মধ্যে কোনটা ঠিক কোনটা ভুল অথবা কতগুলো ঠিক সেটা বার করতে হবে। This is a very easy problem. We have Q equals to Q1 plus Q2 and Q1 equals to C1 equals to C1 plus C2 V, because after adding where the charges are Q1 and Q2, which is distributed through the spheres respectively. So we can write this common potential V. So this and Q1 equals to C1V and Q2 equals to C2V. So Q1 upon C1 equals to Q2 upon C2 from these two. So Q1 C2 equals to Q2 C1. So answer A is the right one. Again we have Q1 upon Q2 equals to C1 upon C2 equals to R1 upon R2, because C versus R. Strictly speaking, C equals to 4 pi epsilon 0 R, where epsilon 0 is the permittivity of the free space, which space is situated inside the spherical body. So we can write Q1 R2 equals to Q2 R1 from these two. So also Q1 R2, so B is answer correct. Again sigma equals to Q upon 4 pi R1 square. Because Q1 upon Q2 equals to R1 from these two, Q1 by Q2 equals to R1 by put here, R1 by R2, cut these two, R2 square upon R1 square. So this is R2 by R1. So sigma 1 is equal to R2 by R1. So answer A, B and C. 12 capacitors, each of capacitance C, are inserted at the sides of a cube made of conducting wires. This cube is made of conducting wires. The equivalent capacitance is to be found out in between P and W. Each capacitor is of capacitance C given. Answer 4 given. We have to find the correct answer. The equivalent circuit is to be drawn first. How? Here is a P, so 3 capacitance coming out from P as PS, as PQ and PU. So we can write this point P, PS, PQ and PU. 3 capacitors coming out from P as PS. You can say if these 3 points are different, why the points coincide here? I am coming after a while. This is W also. From this we can write as these 3 points V, T and R also such like this. Now we can understand that these points and this point why they coincide to each other. Here this is a UV, this is also UV, because these 3 points here, these 3 points here, this is UT, this is also UT. In this way you can find the other, separating this 3 and this 3, you find the remaining 6 capacitors within this circuit. Because this is a complicated circuit and we can write ESQ, the points are a single point in the equivalent circuit. Also VTR, the points at a single point for the equivalent circuit. Why? Now here U, V is the capacitor, here S, ST, here UV and UV and UT. Also SR, SR and ST. Also QR and QB. So these 6 capacitors are arranged in the equivalent circuit such as this, and this is the poison of the problem given. Now it is poison out. We can find the equivalent capacitance very easily now. Here is C. Here is a C. So this is C dash equals to 3C, 6C, 3C, and implies C equals to this is in a series connection, so we can write as the parallel relation in case of resistance, that is vice versa. So we can write C4. So answer is A. Answer A. A circuit is formed using 3 capacitors, this and this. 2 batteries present here. As shown in the figure, choose the correct options. You can take a charge Q, amount of charge Q, which is passing through, this is a plus point, minus point, this point in this way, and in this way, because there is a plus sign in this way, there is a plus sign in this way. And applying Kirchhoff's mesh law, that is second law of Kirchhoff's second law, Kirchhoff's second law, which is called mesh law or loop law. To find the poison out of this problem, suppose this is plus Q charge present here, this is minus Q because this is capacitor, plus Q in the first plate, positive plate, this positive plate, negative plate, also here also minus Q plus Q, here also minus Q because minus Q in this way, and here also minus Q plus Q, minus Q, here is a minus Q plus Q, here is a minus, here is a also plus Q plus Q, plus Q minus Q, plus Q minus Q, here is a plus Q minus Q, plus Q minus Q, this minus Q minus twice Q plus twice Q, this is minus twice Q. Again I am repeating. Suppose the charge coming from this end as plus Q. So the second plate, negative plate will get minus Q charge, no problem at all. In this way also charge comes from this battery to plus Q because this is also 6 volt, this is also 6 volt. This is So also here is minus q. This minus q and this minus q comes here to get also plus q minus q, plus q minus q. So comes to get, here is twice q, here is minus twice q. In this way. So after all, you can write here minus twice q, here is plus twice q. This minus twice q comes here, this minus q comes here. In this way, here is a minus q, here is a plus twice q, and which is earthed. Because this is earthed, so plus twice q cannot be earthed. Here is a minus twice q here, and here is a plus twice q. Again I am saying the plus minus case is not an important thing for a capacitor, because the problem is complicated one. Here is a plus combination, here is also in this a plus combination. So after all, this method comes to an end because this is the earth. So this must be minus to get here earth, and plus, this is plus twice q and this is minus twice q at negative plate. So applying Kirchhoff's second law, we get for the, suppose this is A, B, C, D, E, F, implies, so in this way we get minus q upon C1. Q upon C1 is the voltage potential difference for the first capacitor. So minus q by C1. Here is minus twice q upon C3 plus 6 equals to 0. This is Kirchhoff's second law for the ABCD loop. In this way, when comes this end, we get minus 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 and plus. So after all, we get q upon 2 plus twice q upon 4. Equals to 6, implies q equals to 6. So the charge stored in the C1 6 microcoulomb, because why microcoulomb? Here is microfarad into volt equals to 10 to the power minus 6 farad into volt equals to 10 to the power minus 6 coulomb equals to 1 microcoulomb. So 6 microcoulomb is the answer. Again, so potential difference across C1, potential difference across C1 equals to V1, we get 6 upon 2, 6 upon 2 equals to 6 microcoulomb upon 2 microfarad equals to 6 into 10 to the power minus 3 minus 6, this is 2 into 10 to the power minus 6. This is coulomb, this is volt, this is farad, equals to 3 volt. So V1 is the potential difference across C1 equals to 3 volt, which is not given. So C3, V3, potential difference across C3 equals to twice q upon 4 equals to 2 into 6 upon 4 equals to 3. So potential difference across C3 equals to 3 volt. So this is 3 volt. So this one's right. So answer B and C. The figure shows an experimental plot for discharging of a capacitor. This is a plot figure given where these are the y-axis and these are the x-axis as shown in the figure. So this one is a figure given for discharging when time equals to 50 seconds, then charge discharged as 5 unit and the charge remained as 20. In this way, at time do so 200 seconds, voltage remains 5 volt. At 250 seconds, there is no connection. And at 300 seconds, there is no connection. So, we can write the boundary condition in answer to this problem. The boundary condition as V when 5 volt, T then do so second, 200 second, do so second. In Bengali, do so second, V 5 volt. এই ডায়াগ্রামটা দেওয়া আছে, ডায়াগ্রামটার মধ্যে আমাকে ডিসচার্জিং ডায়াগ্রাম দেওয়া আছে, তার ক্যাপাসিটরের ধারকের ডিসচার্জিং ডায়াগ্রাম দেওয়া আছে, চার্জ ডিসচার্জ হচ্ছে, সেখানে ফর্মুলা আছে আমার ভি ইকুয়ালস টু V0 e to the power minus t upon tau. V equals to V0 e to the power minus t upon tau. How this comes? This comes very easily as dq, as we know, q equals to q0 e to the power minus t by tau. For discharging case, charge discharging. It is discharging case, that is in course of time, the cell is taken out. In course of time, charge is discharging. So at time t there is a q charge, at time t1 there is a q1 charge in this way. So when this one is divided by c, you get v equals to V0 e to the power minus t by tau. This comes here. And why this comes, then you can write dq upon dt. What is this in calculus notation? dq by dt equals to I dq by dt R plus q by c equals to 0. In the circuit for discharging, R dq by dt, this I Ri plus q by c volt equals 0. From this we can get dq by dt equals to minus q by cr, implies dq upon q equals to minus dt upon cr, implies log q equals to minus t upon cr plus log c. Log c is the condition, arbitrary constant, implies log q 0 when at t equals to 0, then total charge present as q0 equals to minus, so log c 0 plus log c implies c equals to q0. So put here we get log of q minus log Q0 equals to minus P upon CR. We get Q upon Q0 equals to e to the power minus P upon CR. We get Q equals to Q0 e to the power minus P upon CR, and this tau equals to 1 by CR. This is the time constant. So we can write Q0 e to the power minus T upon tau. This comes here, and from this here. So we can write, applying this condition, phi equals to, when t equal to 0, we get, when t equal to 0, we get V0 as 25. When t equal to 0, we get V0 as 25. So e to the power minus 200 upon tau. So e to the power minus 200 upon tau equals to 1 by 5. So e to the power 200 upon tau equals to 5. So 200 upon tau equals to log 5 equals to 2.303 into log 10 5 equals to 2.303 into 0.6989. Implies tau equals to 200 upon 2.303 into 0.6989. So ultimately this will get as 124.3. You can multiply this by calculator or by mobile, and then do so divided by this, you get this. If you want to show the answer, answer C. So in this way, if we not approximate this one to this, we get 124.3. This is the answer. So answer C is the correct one. Four plates of equal area. This one plate, this is number 2 plate, number 3, number 4. And are arranged in this way. We have to find the equivalent capacitance in between these two, where A is the area of the each plate and this distance between this plate are separated by, this is D. So we can write this diagram as this one, in this way, because these two are in the parallel connection. So the equivalent capacitance is twice C. Now this is equals to 2 into what is C? C epsilon 0 A upon D. Epsilon 0 A upon D. So answer A. Where epsilon 0 is the permittivity of the free space in between the capacitor, and A is the area of the plate, each plate, and D is the distance between the two plates. This problem is a parallel plate capacitor. In a parallel plate capacitor, a dielectric slab in a parallel plate AR capacitor, a dielectric slab is inserted into the capacitor. So we know when a dielectric slab is inserted totally or partly, the capacitance of the capacitor increases in comparison to the AR capacitor. Now the problem says if the separation of the plate be increased to make the initial capacitance, because if the separation between the plates is increased, then its capacitance will decrease. After that, it will get the initial value, which one is of AR capacitor. So we can write to solve the problem as follows. We have C equals to epsilon 0 A upon D for the AR capacitor, and for the dielectric slab used for that capacitor, we can write this as epsilon 0 A upon D upon K, where K is the dielectric constant of the slab used. Now the parallel plate capacitor, this one is parallel plate plus A and this one is B, which is B. So this one is plus and this one is in this way, in this way. So the distance between the two plates is to increased. Suppose the distance, total distance now is d dash. So we can write as when the In a pellet capacitor, a rubber slab of thickness 4 millimeter is completely inserted into the region between the two plates. By this, the capacitance changes. So, CDS, how CDS will be obtained? CDS will obtained in this way. D epsilon 0 upon, suppose the thickness of the capacitor, thickness of the dilute slab is T. So, D minus T plus T by K, because this is for air and this is for diluted slab used. Now C double dash equals to C. So we have to increase this D as epsilon 0, this divided by D dash minus T plus T by K. If the distance, so D dash can be, so if we consider this 2, we can get D equals to D plus X minus T plus T upon K. Suppose X is the increasing factor. X is the distance which is increased. So dB coming out, so X equal to T whole into 1 minus 1 by K. And from this we get 1 minus 1 by K equals to 3.5 upon 4 implies 1 by K equals to 1 by 8, implies K equals to 8. So answer D. This is the problem again of two capacitors and one battery present here. C1 and C2 are arranged in the parallel combination. We have to find the charge, final charge on C2. Why? First S1 is closed, then battery charge from this will round up through this circuit, and this one is closed, this one is opened at first. So there is no charge distribution in this loop. After that, this one is opened and this one is closed. What does it mean? It means that that charge which one is stored in the C1 ক্যাপাসিট্যান্স এর মধ্যে ধারকের মধ্যে যে চার্জটা সঞ্চিত ছিল সেটা এখন এই সার্কিটে বর্তনীতে প্রবাহিত হয়ে যাবে। কিভাবে? এদের ক্যাপাসিট্যান্স অনুযায়ী যার যতটা ক্যাপাসিটি, যার যতটা ধারকত্ব, তার মধ্যে ততটাই চার্জ যাবে, এইভাবে। সো উই ক্যান রাইট at the first case, দুটো কেস এখানে আছে, ধাপ 1, ধাপ 2। কেস step number 1, step number 1 কি আসছে, when S1 is closed, then the charge going to this, so C1, what will the charge C1? C1 will be 20 into 6 into 10 to the power minus 6 coulomb equals to 120 microcoulomb. C1 equals to, so the charge, what is the final charge? So C1 is 120 microcoulomb. When S1 is now open and S2 is closed, then that charge, suppose C1 charge get Q1 charge and C2 get Q2 charge, then that charge will be distributed in between these two as Q1 upon C1 equals to Q2 upon C2. Why these two is on parallel combination, so the voltage will remain the same, such as Q1 upon Q2 equals to C1 upon C2, implies Q2 upon Q1 equals to C2 upon C1, implies Q2 upon Q1 plus Q2 equals to C2 upon C1 plus C2. So equals to, what is C1? C1 equals 6, 6 upon 3 plus 6, Q2 upon 120. So total charge equals to 120 equals to 6 upon 9. Implies Q2 equals to 40 microcoulomb. So the final charge answer C. So this is all to the to this class. We shall meet you again at the next class. Thank you everyone. Happy Diwali, happy Kali Puja. Previous year we haven't festivated ourselves at this occasion. So enjoy this festival as far as possible. Thank you.